Hello and welcome in. My name is Mark. This is the first in a series of videos I'll be making on FreeCAD. FreeCAD is a free CAD software. I'm using it to make 3D models for my 3D printer. I've been using this for a few years now. I just thought I would go ahead and make some videos showing people how to use it. Let's take a look at the website. This is the freecadweb.org website here. You can click the download link to download. It has versions for Windows, Mac, and Linux. Instructions here in the wiki on compiling or installing on Linux. The app image here is a file that you would download, mark it executable, and execute it. These both would be files you would install on the computer for Windows and Mac. I will be using 0.19. This is not installed, it's just extracted, and you go into the folder. This is on Windows. Let me go to the releases page. I'll be using the 0.19 pre-release version. You might need to expand the assets tab here. I am using this one, the Python 3 Qt5 version, using libpack 12.12. These files are in 7-zip format. You download the file, extract it, open the folder, look for the bin folder. Inside the bin folder is the FreeCAD.exe file. That's on Windows. On Mac, the DMG file you would install. And here's another app image file for Linux. These libpack files are for if you want to if you want to compile, you would use these. Compiling on Windows. The 7Z format is used by 7-zip, which is a file compression utility. You would go to 7-zip.org, that's the number 7-zip.org, to get that software if you don't already have it. Most of you probably will. Now we'll go to the software. Oh, one more thing. If you want to get help on using FreeCAD, there's a forum. Go to community forum. Sign up for the forum and you can ask your questions here rather than ask in the comment section on the video. There are people on here who are quite knowledgeable, eagerly awaiting your question. And that would be in the help section. You can also look through a user showcase section to see some examples that other users have used FreeCAD to create some of their other models. And also on help on installing and compiling, you can get help here. Let's go to the help section. All of the questions here, we see the subject title. Click new topic to create a question. In your subject, use a subject that tells people what you're asking about. If you just say, help me please, that's not a good subject. It would be better to say something like help on Sketcher, for example, if you need help with the Sketcher. Another tip, include a screenshot. You can drag and drop right here into this box where you type, or down here in the attachments, add files. Another tip, include your FreeCAD file. And fourth tip, include your FreeCAD version information. So 4 tips for you: a useful subject title, screenshots, FreeCAD file, and FreeCAD version information. The FreeCAD version information can be added in the help menu, help, about FreeCAD, copy to clipboard, and then you can just paste it in. All this information is very helpful to the ones who are trying to help you, because depending on which version you're using, the answer might be different. The procedure might be different. And here, what says important, click and read before asking for help, go ahead and click that and read that. Now let's go back to FreeCAD. This is a sample file that's included. I did not make this model. Let's talk a little bit about this screen here. I'm using Blender navigation mode. You see this icon at the bottom? You can click it and choose the different navigation modes. I'm using Blender. It works best for me. I believe CAD is the default. So the instructions I give on manipulating in FreeCAD are specific to Blender. It might be different if you're using a different navigation mode. To zoom in or out, I scroll the mouse wheel, roll it forward and back to zoom in and out. You zoom in where your cursor is located. To tilt the display, hold down the mouse wheel as a button, click it, and then move your mouse. To pan, hold down the shift key on your keyboard, click the mouse wheel button, and pan. So that's navigating in the 3D view using Windows, Blender mode on Windows. If you're using a Macintosh, possibly the Control and Shift key functions might be a different modifier key. I'm not sure, I don't have a Mac. We'll go ahead and close this model, discard changes. The first model we're going to make is going to be a very simple, trivial model. It's just going to be a section of pipe. You might imagine needing this for some project you're working on. Maybe you need a little piece of pipe. Maybe you're repairing your vacuum cleaner or something. So that's the motivation. This is not a real project. First thing to do is create a new document. You can do this in File menu, New Document. Switch to Part Workbench. We're going to be using Part Workbench in the first part of the series, and then we'll move to Part Design after that. There are a number of workbenches here. Do not let that intimidate you. The only one to worry about right now is Part. If you don't see this selector control, you can do this from the View menu, Workbench, and select from there. The type of modeling that I think is easiest to learn FreeCAD with in the beginning, to me it seems more intuitive, even though it's not necessarily the best way to model, but it's the best way to get started. We begin with geometric primitives. For example, we have a cube. Let me add one just to show you. This is a cube object. It's called a cube. It's really a cuboid. The difference being we can modify the height, width, and length individually, whereas a cube implies they're always the same as each other. In the left-hand side of the screen, there is a combo view. That's this panel here. The combo view consists of two other views. The tree view, which is at the top, TREE, and the property view on the bottom. When you select an object in the tree view, the properties of that item are displayed in the property view. Each item has two classes of properties, the data tab here, and the view tab here. The view properties modify the look of the object on the screen. For example, the color or the transparency. The data tab is where we'll spend most of our time. This modifies the geometry of the object. In this case, for a cube, it's the length, the height, the width, and the placement. The placement defines where the object is in 3D space, the location, and the rotation. We'll talk more about placement in later videos. You can do an entire video just on placement property. So we could use this cube to represent, for example, a sheet of plywood, or a door, or a shoebox. It's a starting point for your model. You'll see an arrow here in the report view. On the bottom of the screen, I have the report view active and the Python console. FreeCAD is written in C++ and Python. You can enter Python commands directly into the Python console, and often when you use the graphic user interface, the GUI or GUI, the things you do in the interface get echoed and actually are implemented in Python. You can see when I change the length, each time it echoed to the Python console. So I could type this in and create a command to be executed. This is useful for some commands that might not be available otherwise, or also you could create a little program and type it in. If you want to be a little more elaborate, you can create a macro, which is a Python script to interface with FreeCAD. We'll probably cover that later on. If you want to take Python to the next level, you can create your own Workbench to be included in FreeCAD. And there are a number of these that the community has already provided. Let's look at that. In the Tools menu, Add-on Manager. Here we can install workbenches and macros. Let that download. So these are the macros available. Let's just grab one. And this is already installed on this computer. Find config files is used to locate your configuration files. which can be different on different operating systems. Sometimes if you have trouble with FreeCAD, or if you just want to reset all of your settings back to default, this will help locate those files. Use system CFG and user CFG. And workbenches here, you can install workbenches that users have contributed to the community. Some of these are quite good. The quality will vary, obviously. Now, let's look at this error message. Length of box is too small. That's because I have 0 length. That's impossible. So I'll put that back to 1. I can right click here, clear this, and that way if there's another error, it'll catch my attention. By default, the report view is not visible. You can set that in the view menu here, panels, and choose which ones to look at. Notice the tree and property views are separate from the combo view. The combo view consists of both of those, so you can have them independent of one another if you prefer. I like just using the combo view. So with it's called constructed solid geometry, I believe. With this method of or style of modeling, you begin with these primitives like the cube, like the cylinder, the sphere, and size them to your needs, and then combine them using what are called Boolean operations. As an example, let's suppose this was a door and we wanted to cut a hole in the door. We can do that with a cylinder. We can bring the cylinder in and we can rotate that cylinder. I'm going to right click, choose transform. It's a handy tool for moving objects around. Okay. And then we can cut that hole in that door with the Boolean Cut. Or we can use a Boolean fusion to make that into one single object. Or we can take the common, which will return only the intersecting part where these two objects both are contained in the same space, where they overlap, in other words. So to cut, you first select the object that is the base, the base object, and then hold down the control key on your keyboard. Again, on Mac, this might be a different key. The CTRL control key. And then select the cylinder next. The cylinder will be the tool. The cube is the base. The cylinder is the tool in this example. It's the cutting tool. We're going to remove the tool and any parts that it overlaps from the base. And we can do that from part menu, Boolean Cut. So now we've cut a hole. In the base. And now we have a cut object. Cut object has its own properties. Notice how base is the cube and tool is the cylinder. They both disappeared. The cylinder and the cube have disappeared, but they're still here. We can expand here, and you can see that these objects are still there. They're just invisible now. We can toggle visibility with the space bar. Click the object and hit the space bar to make it visible and invisible. So in a nutshell, this type of modeling, you begin with a primitive object such as a cube. You modify it, change its properties to meet the size and the location that you need it at. You might add another object, like I added the cylinder, to use as a cutting tool. And then I did a Boolean cut operation. And that's really all there is to it as far as the CSG modeling technique. We have a lot of other tools that we'll cover here in later videos. I'm going to delete this file, discard changes, and we'll make another one. This time we're going to make a little piece of pipe out of 2 cylinders, and we're going to use a spreadsheet to hold our variables. This is going to make the model parametric, and by parametric you can change the variables such as dimensions, and the entire model will adjust itself to the new settings. So we create a new document. We can do that here. This is the start page. Some of my icons are missing. You might see a preview like here in examples on your screen. So we'll create a new document. We're going to add 1 cylinder for the base and another cylinder for the tool. The tool will be a little smaller and it will cut it out of the base, and that'll make our pipe. Let me go ahead and label these. I'm right clicking, choosing rename, and I'm going to call one base and the other one F2 to rename. I'll call it tool. They're both the same size right now. Make the base just a little bit bigger. Now I want this piece of pipe to be 4 inches long, a 1 inch internal diameter, and I want the wall thickness to be 1/8 inch. I am in millimeter mode, which is the default. I'm going to leave it there, and I will still be able to use inches. I'm going to create a spreadsheet file, a spreadsheet object to hold the variables in, to consolidate them into one location. So we switch to the spreadsheet workbench to create the workbench. I'm going to do it from the view menu, workbench, spreadsheet, and from the spreadsheet menu, create spreadsheet. I'm going to relabel this also to simply SS, so I can save some typing. In the A column, I'm going to name my variables, and I'm going to prepend each name with also SS underscore length. This will be the length of the pipe that I'm going to make, or the I'm calling it a pipe. You could call it a tube. The next variable will be inside diameter, which I'll just call ID. The next one will be wall thickness, which I'll just call wall. Notice I'm using underspaces instead of underscores instead of spaces. Spaces are not allowed in variable names. Now this is only labels here. In column B, this is for my convenience. So when I look at the spreadsheet, I'll know that this in column B is the length. This is the internal diameter. This is the wall thickness. I need to create an alias for each of these cells because I want to refer, instead of referring to the cell as B1, which I could, I want to refer to it as the length. I want a variable name. It makes more sense and that I can remember easier. So I right click, choose properties, and in the cell properties dialog, I want the alias tab, and there's where I enter my alias name. And I'm going to use the same value as what's in that label. And now you see a yellow background. When you see a yellow background in the spreadsheet, that indicates you have an alias set. When you hover over it, you see the tooltip gives the name of that alias. The alias is what's key. It's not what's in this box here. It's the alias for the cell. We'll make one for this one. Right click, choose properties, alias. Click in here, SS_ID. I'm using SS. It's a little trick. Later on, I'll be able to just enter ss.ss and up will pop a list of all of my variables. If I didn't do it that way, I'd have to remember all these variable names, and I'm going to forget. Did I call this wall? Did I call it wall thickness? Wall underscore thickness? I'm going to forget these names. So let's make one more for this one. Right click, properties. Come over to the alias tab. SS_wall. And OK. So I said I wanted this to be 4 inches. I'm going to say 4 times 25.4. I put the 4 in parentheses. It's just a habit to get into when using fractions. If later I came back and wanted to make this 4.5, I would be able to just say 4 plus 1/2 and it would work. If I did not have the parentheses, I might come in accidentally and say 4 plus 1/2, and this would not work. This would not be a valid, it would not give me what I was expecting. Need that parenthesis in there. Press enter. Okay, so I just want 4 inches for now. The internal diameter was going to be 1 inch. I should probably make this radius instead, but I've already entered that. So 25.4 is how many millimeters there are in an inch. It's exactly 25.4. So that's the reason for that. We're converting inches into millimeters. And here for the wall thickness, 1/8 times 25.4. My parentheses are not being carried forward. That's okay. Now let's go to our base. So I want this radius to be the tool radius plus the wall thickness times 2. Wall thickness times 1. I'm going to press the FX icon. This brings up the formula editor. FreeCAD has something called the expression engine. Expression engine is used to reference properties from other objects. So I'm going to reference aliases from the spreadsheet for the value of the properties on these two cylinders. So this is going to be ss.ss. You see how the list came up with the variables. ID plus ss.ss wall. This should be ID over 2 because that's diameter, not radius. And now this blue check mark indicates that the object needs to be refreshed or recalculated, recomputed. This will happen automatically when we select a different property box or a different object, or we can manually press this icon or press F5, and now we have the outer diameter set or the outer radius set to what we want. And the tool, click here. You can also press equals on the keyboard to bring up the expression engine, or you can click the FX icon. ss.ss, and what I want here is internal diameter divided by 2, since this is radius that we're entering. And now when I click on the height, you see it updated, it recomputed. So here's my base, here's my cutting tool. Now what's left is the height, which is the length. So let's set the base height. I'm going to press the equals key on the keyboard as a shortcut. ss.ss, come down to length, press enter. I can do the same for the tool. Click the height property, equals key, ss.ss, come down and select length, and OK. F5 to recompute. So our pipe is coming into shape now. What you're seeing here is an artifact. It's a little bit of a bug in, I believe the bug is in Qt. This is a well-known bug. To fix this, click this icon here to fit the whole content on the screen. I'm not sure exactly what it does, but it fixes the problem. Now we can make our cut. Select the base first, hold down the control key, select tool. The order of selection is important. base first, cutting tool second. And we need to go back to the part workbench to use our cutting tool. We can do it here from the toolbar. And now we have our pipe. Now I can save this file, save, and I'll call it pipe. By the way, you should save early and often, because FreeCAD is still a work in progress. You can still have occasional crashes. It would be frustrating to lose all your work. So save and save often. Now we can export the cut as an STL file, import it into, I'm not going to go into that, but go to the file menu, export. Sometimes I use the additive manufacturing format. Sometimes I use the STL format. Sometimes I use a wavefront OBJ format. All of these work with my 3D slicer, which is called Cura. So give it a name, export it, and then import it into your slicer if you're going to use this for 3D printing. If you need to export to other, you need to select your object first, which is the cut, and then export it. If you want to export to a different software, a different format, such as one of these for a different CAD. The WebGL format will create an HTML file that you could put on the web and interact. Users of the website would be able to manipulate the model. So that's pretty neat. I'm going to cancel that. Notice how the base and the tool, these are dependencies. The cut is dependent upon these two objects. They're still there. They're hidden. We can still modify these objects, and the cut will automatically update itself. The advantage of having this all consolidated into a spreadsheet is that we can go in now, we can change our length to something like, I mentioned a while ago, 4.5, 4 plus 1.5. Enter. You see the value updated here, and it's a little bit longer. Can't really tell that it's longer, but it is. And notice, because we made it in this manner as parametric, and the base and the tool both automatically adjusted their heights. One problem you might run into, which I did not hear, when your base and your tool are the same exact length, you might have trouble with the cut. These are called coplanar faces, and sometimes coplanar faces can give you problems. If you run into that, just make the tool a little bit longer so that it sticks out further on both sides. Make it a little longer, move it down a little bit, and that'll solve that problem if you run into it. This is going to be it for this first video. I'll be making more videos later, and we'll be describing some of these other options that are available, some of these other tools that we can use also in the part Workbench. Thank you for watching, and have a great day.